chain molecules. They are very good. This one, the plastic materials and polyethylene are the best example for the polymers. Okay, even the plastics. Okay, and the composite materials, just a small introduction to this. The composite materials are reinforced made by using the metals and non-metals by reinforcing them. Okay, even the roots of the fibrous materials, the trees, and some of the plastics and rubbers, all these are laminated together to make the required shape directly by line technique, the composite materials. And they are even they'll be useful for many other applications. Their cost is very less. Okay, today the composite material costs have become less because the fabrication technology have been improved. And among them, the composite materials, we have two types: fiber reinforced plastics, FRP, and carbon reinforced rubbers. Okay, the fiber reinforced plastics and carbon reinforced rubbers. You can see that plastics and the rubbers. So wherever you require to have some elastic properties for the materials, the carbon reinforced rubbers will be used. Wherever we don't want to have, you want to have very good the structure. So for example, you want to make a gear, you want to make a car body, you want, and another one you can see that your car body today is many of the car bodies are coming in the composite materials. The deck and all is you are going to find out within the cabinet and all, the seating arrangement and the driving wheel, all these are made out of the composite materials. Okay, and these are the basic four categories of the materials. I am going slowly in order to make you to understand. The four basic important materials are metals and their alloys, the ceramics, polymers, and the composites. The metals means again the ferrous metals and non-ferrous metals and their alloys will come. Okay, they'll be hard in nature, they'll be having very good durability, and they have ductility property. They can be malleable, they can be made into sheet, they can be made into wire, ductile, and they are very hard. Okay, that means they cannot allow other bodies to indent in them. Okay, and they are opaque in nature, and they can be made into ornaments like that. The metals will be coming the family. The ceramics are those will be ceramics. Ceramics are by mixing the metal and non-metallic elements together to make heavy, the very hard in nature. Just like I want to make a cutting the wheel. Cutting wheel I want to make. I want to make a emery paper. You have seen that houses and all, the doors and all, and even the walls. Before you go for the painting, a paper will be there, emery paper. They're going to rub it on the wall so that the paint and other the particles will be removed. The other grit size will be used. Various grit size. You want to make a roughness. You want to make a smoothness. So different the combination of the sizes they'll be using. Those are all called the ceramics. And other hand, the polymers are the derivatives of carbons which have the long chain 3D structures. Okay, that means they can be make into bulky material. Bulky material. You can see that the rubber, if you put a pressure inside, what happens in all the 3D dimensions? They'll be increasing their volumes. Elastically, they'll be extending. So those are all will be coming under the polymers. Okay, the composites, polymers, ceramics, and the metals. Very important, the families. Now let me come to the metals. I told you already, metals and their alloys, they're falling into two groups: ferrous metals and their alloys, and non-ferrous metal and their alloys. So the metals which will be having the magnetic properties, those all will be coming under the ferrous metals. Very simple way, the ferrous metals are those will be having the carbon content in them, and the percentage of carbon varies from 2 to 6 based on the applications. Okay, so those are all the ferrous metals. You can see the ferrous metals, they are again four important categories: pig iron, cast iron, wrought iron, and the steel. Pig iron, cast iron, wrought iron, and steel. And the pig iron is directly extracted from the iron ore, which will be having the more carbon content in it. Okay, it will be having more carbon content in it, and it will be tougher in nature, tough. Okay, and this is a crude iron ore, iron extracted from the ore. Okay, and the cast iron is the other one. It is a pure form of a pig iron. The pig iron will be extracted from the furnace. In the furnace, what we are going to do, iron ore will be put into the furnace, and we are going to put a high temperature, and what happens, the pig iron will be extracted, separated out, okay, from the furnace. And the cast iron is a purified form of a pig iron. It will be having a carbon percentage varying from 2 to 4%. Okay, all these will be useful for the some engineering applications. The cast iron, you can see that in front of your house. The very simple example, you can see your sump will be there, water sump. On the water sump, some covers will be made, and if you go on the way, some the drainage covers will be made. All this will be made out of the cast iron. The cast iron will be identified by its toughness, and it is not ductile, it is a brittle material. If you throw it, what happens? It will be not bend, it will break. The cast iron will be breaking because it is having very high carbon percentage in it at the same time. Okay, cast iron is a tough in nature, it will be a plastic in nature, and it will not be elastic. Okay, it will be useful for some other various applications. The wrought iron, it is cast iron. The iron, when we are going to mix with the silica and other the composites, other compositions. Okay, if you are going to add some silica and some other elements, you can see them. If you are going to mix some other elements along with this, then what happens? No, we are going to remove the impurities present in the cast iron. Then it will become a wrought iron, and this wrought iron will be very tough in nature, and it is malleable, and it is ductile in nature, and all these can be used for the railway tracks and railway wheels. Okay, those will be subjected to impact load. All these will be made out of the wrought iron. And the steels are widely used alloys of iron. The steel is a alloys of iron. Okay, alloys of iron, and in this we will be mixing the carbon certain percentage. The sulfur will be mixed with silicon, will be mixed, manganese will be mixed. All these will be mixed up because we want to have certain improved properties of the metals. You should have to avoid the corrodiness. Corrosion should not place at the higher rate, and it should have very good hardness. It should have, and it should have the very good elastic properties, because I have to make it into certain component. Then I can able to make a machining. Once it is ductile in nature, I can able to make into different components. Okay, so all these various properties, the hardness property, ductility property, and increase avoid the corrosiness, and to make into thinner, ductile, malleable, all these different mechanical properties can be obtained by mixing with some other combinations like sulfur, silicon, magnesium, and the carbons. Okay, and these are called the steels and steel alloys. Okay, steel alloys. So these are the important things. Okay, the ferrous metals are magnetic in nature. The ferrous metals are having the carbon content in them, and these ferrous metals are classified into 4 important types: ferrous and their metals. Pig iron, cast iron, and wrought iron are the direct metals, ferrous metals, and steel is a ferrous alloys of metals it is. Okay, and you can see them. Pig iron is obtained directly from the crucible by melting the iron ore. Okay, it is having toughness in nature. It's not a good ductile property. Is not having. It can be made out. Can be casted to the required shape. Casting is what? The casting is one which you are going to make small the statues and all. For example, I want to make a statue. Okay, the statue. What we are going to do is we are going to take the cope and drag, and the sand will be filled into that, and we are going to make the impression of this statue and make a small hole on the top, pour the molten metal into this cavity, and which will be achieving this statue. I'll be showing you. Once you come to the college, I'll show you how the casting will be made, how the cavities will be made by using the green sand. I'll be showing it. It is one of the interestful topic. Okay, and the cast iron is the next version of the pig iron, and it will be obtained. It is all these are not directly available from the earth. From the iron ore, all these will be extracted. The cast iron will be having the carbon content in it. It will be again the grey cast iron, white cast iron, malleable cast iron, alloys cast iron. All these I don't want to make you put you into confusion, because understanding and remembering the name, it will be slightly difficult. Try to understand the second level only. Ferrous metals. These ferrous metals are a pig iron, cast iron, and wrought iron, and the steel. And the cast iron will be having a brittle in nature. It is not a ductile, it is a brittle, and it is not having elastic property, it is having the plastic property, and it can be casted, so that these are called cast iron. This can be casted to the required shape. In most of the machineries cover, most of the component covers, okay, all these will be made out of the cast iron. Those cannot be done by machining. Very complicated shapes can be obtained by using the cast iron. But one thing is that the cast iron cannot be casted in a thin sheet. If you make it into thin sheet, very weak in nature. You cannot make a car body and all. At least a 4 to 5 mm thickness, if you want to maintain, it is possible to make by means of a cast iron. Okay, how we can find it out? The cast iron, just by naked eyes, we cannot able to find out what this cast iron is. By looking at its properties, we can say this is a cast iron, this is a wrought iron, or this is a steel. If we throw it or give the impact load onto the cast iron, it will break, it will not bend. That is one of the nature. It is a plastic in nature. Okay, plastic property. Plastic will break, it will not bend. Okay, and the wrought iron is one which is other the category of the ferrous metal. This wrought iron will be having very high hardness, and it is elastic in nature, having a good percentage of carbon, and it will be having wear resistance and corrosion resistance. So due to these properties, this can be used for the heavy duty low works, just like the railway tracks and railway wheels, railway axle, and the gears. All these will be made up of the wrought iron. Next, coming to the steel, steel is one which will be having the percentage of carbon from 0.2 to 4. Based on the requirement, this carbon percentage will be mixed. Along with that, silica and some other elements will be mixed. Metals will be mixed, because to improve the other properties. A metal which will be having very good ductile property may not be having the hardness. To improve the hardness, other silica or some other property, some other things will be added, like that. Okay, you can see here the carbon, sulfur, silicon, manganese, and other alloys, other things will be added together to improve the mechanical properties of the metals. So these are called the steels. Okay, these are called the steels. And you can see that the Indian history, if you look back, the Ashoka pillar, even today the scientists, they could not able to find out what is the composition of Ashoka pillar. Even many people, they are working on this, because it is not trusting at all. Totally, it is there, even though it is linked to the various temperature, various operating pressures, and various climatic conditions, it is lead. Then, even though there is no rust formation on the surface of the Ashoka pillar. That means in the ancient days only, our forefathers were knowing the technique of preparing the metals, Okay, even some of the weapons we can find, we are in the earth crust around more than 1,000 or 2,000 or 3,000 years back. Those are made out of the metals. You can see the metallurgy, how they are using earlier days. So it is our responsibility to understand basically what all the different materials will be useful for the different applications. Once after you are applying your creative ideas and knowledge, then get out a physical outlook to our creative ideas, understanding the basic materials and their usefulness is also a very important thing. Then only it will become a complete cycle of design. Otherwise, it will be half. Okay, so this is what I wanted to say. Then the last today's topic, the applications of ferrous metals and their alloys. One of the things I want to say, from the kitchen to the sky, all these have got the applications. Kitchen, you are going to make the cookers, you are going to make the spoons, you are going to make the stoves. Okay, from there to the structure of the house. One by one, let me get into this one. So before you talk about these, the ferrous metals and their alloys, the ferrous metals and their alloys have got very wide range of applications. The applications are from the sky to this kitchen. The first one, the structural. For the reinforced concrete building, we are going to make the fabrication of gates and the grills and the steels. Those will be sandwiched in between the reinforced. And automobile, we are going to make the gearbox, the gears, the axles, the body parts, or the chassis. All these are the automobile applications. Marine applications, the ship hulls, the engines, the turbines, blades. Okay, there also again the axis and the body of the marine. All these will be the ferrous metals. And defense applications, you can see the tankers, weapons, guns, shells, structures, so many other. All these will be the ferrous metals and their alloys. And some of the consumable product like the home appliances, toys, tools. Okay, all these are coming under the ferrous materials. And if we get into the industrial applications, wherein for the primary manufacturing process, even for the secondary manufacturing process, you are using some of the tools to get the shape for the metals, just like the cutting tools, machine tools, jigs, fixtures, and some of the holders. Okay, all these will be coming under these ferrous metals and their alloys. So broadly, please look into these structural applications, automobile applications, marine applications, defense, consumable products, okay, and industrial applications. These are all the applications we find. Or if you feel difficult to write them up, you can summarize and write. Okay, the steel which you are going to use for the reinforcing of concrete, we are going to make the grill gates, safety gates, and all these from the ferrous metals. We are going to make the gears, gear assemblies, gearbox, axles, and body parts. Okay, sheet metals and the chassis. All these are the automobile applications. Marine applications, ship hulls will be made, and turbines will be made. The engine body, engine cover, engine. Okay, the transmission systems. All these will be marine applications. Defense, the tankers, the different weapons, the guns, shells, all these, and consumable product from as far as the home appliances are considered applicable. Toys, tools, home appliances, your kitchen items, all these are the ferrous metals. And industrial application, even the non-ferrous also will be used. Please understand. Okay, let me put this question last. Industrial applications, the primary the manufacturing process and secondary manufacturing process, we are going to use some of the machineries. Those can cut down the metals into required shape, and they can machine the metals into required shape. Those will be coming under the industrial applications. These are all the things I wanted to complete today.